Well, integrate by parts is a very useful method, a very useful technique in integrations. It comes from this, right? You have a UV. UV are functions of x, and you take differentiate. This becomes a u dv, right, plus v du. That's called product rule. Now, if you integrate both sides, and you have a uv is equal to integral u dv plus integral v du. And you move this over there, so therefore u dv is equal to uv minus integral v du. Okay, this is we call it integrate by parts. Okay, that means that when you integrate u and dv, it's not easy, not nice. No, we change the order. We change the v du. It might be easier for us. Okay, now very, very useful, very practical method in dealing with trig functions. But what I'm doing here is that I want to simplify the writing. Now, instead of when you deal with the integral, you write let u be something, let dv be something, or you write d is d something, I something, and then you have many side explanations, side works. So what I'm doing is a straightforward, without any interruption. I would like to share my own experience. Okay, let me have examples. Let me show you examples. For example, you have a integral x squared e to the x dx. Obviously, this integral is done by parts, right? But what I'm writing is that I do not write a u and a v. Do not show what is a v, what is a u, and do not have a side explanation, side works. So I'm writing this way. I write x squared d e to the power x. Okay, if I write this way, obviously this is a u, this is a v. U is x squared, v is e to x. So by the method of by parts, this becomes uv. U is this, right? V is this. Minus v du. Minus integral v. V is this. Du is 2x dx. You see? I don't have to show what is a u, what is a v. And this one is equal to x squared e to the power of x minus, I take 2 out, and x, right? This x, and the d e to the power of x. Because d e to the power of x is equal to e to the power of x dx. So just change the form of writing. In this way, I don't have to show what is a v, what is a u. So obvious. This is a u, this is a v. So this is x squared e to the power of x minus 2 bracket uv, right? U and v minus v du, integral v. V is this. Du is dx, right? So this one equal to x squared e to the power of x minus 2x e to the power of x plus 2, right? Okay, it's done. From here to here, straightforward, no interruption, no side works, no side explanations. Just so. This is my own experience. I think this is a very nice way now to do by parts. Let me have another example because this is a little simpler. Okay, let me have another example. A little complicated. How about e to the power of a to x and the sine bx dx. Okay, you know this kind of integral has repeated by parts to apply. Now, I have to decide what is u, what is v, right? But I don't show out, This is equal to integral. One of them is a u, one is a dv. I write to say this is my u, sine bx, and this is my v. But they are not equal because this de to the power ax is a times e to the a. I don't have a here, so I delete that a by multiply 1 of a. Okay, so then it's equal. Right, it's equal. Obviously, this is a u, this is a v. So this is equal to 1 over a, and uv, u times v, right? Is sine bx times e to the power of x, but I'm writing this way. Okay. Sine b of x. This writing is better, no? If you write e to something here and it's ambiguous, it's a sine bx e together. So this is a minus v du, right? V du. V is this. Du is a v. Du is what? Du is a cosine bx times b, right? B take out, and dx. Correct. Has to be very careful. Now, this is equal to 1 of a e to the power ax sine bx minus b integral. Now I have to decide what is u, what is v. According to my experience of by parts, that you have to keep going with the same u, same v. So I do this one as my v. Then this is my u, right? And not equal because this one is equal to a times e to the. I don't have a here, so I divide by a again. Now it's equal. Then this one is equal to that's correct. 1 of a e to the power ax sine bx minus b over a bracket. Now here uv is very clear. This is v, this is u, uv, right? So this is e to the power of x and the cosine b of x minus integral. V du. V is this. Du is the negative sign bx times b outside, right? Dx. Well, hope you understand. So this one is let me organize it again. So this one is 1 over a e to the ax sine bx minus b over a square, right? Multiply e to the power ax cosine bx. And this negative can be positive, right? And the b outside. And this is e to the, okay, same thing as I, right? This is I. So this is bi. Yeah. Okay, this is my original integral. Then I move this one. Okay, this is b squared. Right? Then I move this one is 1 plus b square a square I is equal to 1 over a e to the power ax sine bx minus b over a square e to the power ax and the cosine bx, right? Okay, plus c. No, I haven't done yet. It's still the integral there. Now then, my I is this, right? This is a square over plus b square over a, right? No, this is a square, right? A square. Wait a minute, there's some things. This is b square. This time is b square. Okay. This is b square. This is b square. This is a square. So this becomes upside down. This is a square. This is a square plus b square multiplied by is 1 over a e to the power ax sine bx minus there's some kind of mistake. This is times the b square, yeah. This is b, sorry. I still have missed it. This is a b, yeah. This is bi, so this one time this one's a b. This one time this b, the bi with this one, yes. Okay, then this is a, sorry, there's always some errors. This is b, this is a square, e to the power ax, and the cosine bx. Yeah. Then finally, my I is equal to this is a square plus b square. This is a common factor, a to the x. This one times this one has a left, sine bx minus this one, a cancel out, square could be b cosine bx plus c. Yeah. That is the very answer. Okay, so what I'm doing here is that I'm repeatedly using by parts, but I'm not showing what is U, what is a V. Everything is in the writings. This is my way of doing by parts, and hopefully this is useful to you. Okay, thank you for your watching.